As we all know, greenhouse gas emissions from the past few centuries have been contributing to climate change, a problem with significant global consequences. For the most part, efforts to combat climate change have focused on reducing emissions, but by many estimates, CO2 will need to be removed from the atmosphere for climate change to be reversed, a set of processes collectively known as CCUS, or carbon capture and utilization or sequestration. Sometimes, however, these do more harm than good. To explore these techniques, this video focuses on the question:
how do our options for safely locking up waste greenhouse gases compare with their impacts on the environment and on society?
Hi, I'm Henry Chen. I will be talking about artificial CCS.
Hi, I'm Alexander Dial, and I'll be talking about carbon capture and utilization.
Hello, I'm Jarek Lee, and I'll be talking about biological approaches to sequestration. Ladies and gentlemen, may I present to you Group 53.
A major part of carbon sequestration is carbon fixation, which is the conversion of inorganic carbon molecules in the air into organic molecules that reside in living organisms. This primarily happens through a process called the Calvin cycle. Now, in the Calvin cycle, carbon dioxide is fixated into two 3-carbon compounds. Then, one of the molecules leaves to form glucose, and the rest regenerates, allowing more carbon to be fixated. This cycle naturally takes the carbon dioxide out of the air and uses it in a living organism. Scientists can utilize carbon fixation by planting more trees, promoting anything with a chloroplast, really. However, one recent idea is to use the organisms in the world's largest carbon sink, the oceans, to take carbon out of the atmosphere. That is to say, this thing. Naturally, phytoplankton or oceanic algae absorbs carbon, then sinks to the ocean floors, taking that carbon with it for a few centuries. However, scientists think they could induce more algae by adding more iron. In 2012, in the journal Nature, scientists seeded a small section of ocean with iron, which promoted a lot of algae growth, which ended up taking a lot of carbon out of the atmosphere, showing a proof of concept. There are numerous benefits to such an operation. For example, the cost would be very little, as such a fine layer of iron would suffice. Furthermore, it wouldn't take up any of our living space. Lastly, it would take out an incredible amount of carbon. However, on the flip side, doing so would completely destroy the oceanic ecosystem, as algae blooms would steal all of the necessary nutrients for other animals to survive. Therefore, its usefulness is only as a last-ditch effort to reverse climate change.
Greenhouse gases can be removed from the atmosphere or for exhausting using membranes obstruction obstruction, after which they need to be transported to a place where they can be locked up. CO2 is often transferred to oil fields and injected for oil extraction in what is called enhanced oil recovery. It can also be stored underground in pressurized or aquatic plants.
Rather than merely storing greenhouse gases, they can be incorporated into products, a set of processes known as carbon capture and utilization, or CCU. Such technologies include air carbon, a plastic made from dairy farm emitted waste methane, covestral polyols made with CO2, synthesis processes for methanol, urea, and other industrially useful chemicals from CO2, and processes that use CO2 to produce carbon neutral ethanol, diesel, and other such fuels. On the positive side, CCU technologies produce something useful, sometimes even profitable, allowing them to lock up waste greenhouse gases and mitigate climate change with less or even no government funding. Also, these companies and products from CCU technologies would result in job creation and other economic benefits. However, even if the entire chemical industry used CO2-based chemicals as primary feedstocks, only a small fraction of waste CO2 emissions would be consumed. CCU can't do the whole job. All of these methods of CCUS have positive and negative impacts on society. All contribute to mitigating climate change, helping prevent the environmental destruction as well as the refugee crises, resource wars, and other societal ills due to climate change. CCU would also bolster the economy, while climate change prevention would protect it. Biological carbon fixation is a biological means of doing the chemical process of CCS. Planting trees and algae seeding both fix carbon, but algae seeding would destroy the oceanic ecosystem, thereby also destroying some industries. All of that said, we need to find some method of controlling our emissions of greenhouse gases, if we are ever to have a hope of human survival.